Moving on to the Devonian extinction, we will call it December 1st or 2nd. This is the second major extinction event to occur on planet Earth. The exact time span of this event is uncertain, and the exact cause is difficult to pin down due to the duration of the extinction. For this presentation, we will be focusing on weathering, anoxia, and global cooling as it relates to this extinction. During the late Devonian, plants had fully transitioned to land and now included large lycopsids, sphenophytes, and progymnosperm trees. There was also significant tectonic uplift during this period. Newly introduced trees had a much larger root system, which broke up the soil. Coupled with plate tectonics, erosion rates increased significantly. Eroded material would have included soil, organic debris, and rock fragments, which were ultimately transported to the oceans. The incumbent sediment would have negative effects on shallow water biota, accounting for some die-off. But the main killer would be a massive algal bloom. Eroding sediments serve as sort of a multivitamin for algae, especially if in high abundance. The algae feed on the sediment, become all fat and happy, and bloom. Algae blooms can consume much of the available oxygen in the water, making the local water column anoxic. Large algae blooms also block out sunlight necessary for photosynthesis to take place. And lacking the means of making food, the photosynthetic organisms below die off, as does everything that feeds upon them. The blocking out of the sunlight also decreases the temperature of the water, especially in the absence of a new carbon dioxide source. As the organisms in algae die, they take their carbon with them. And if rapid burial occurs due to tectonic uplift, the carbon would become locked up in the lithosphere, aka in the rock, making beds of coal. This would lock up carbon from the carbon cycle, prohibiting it from re-entering into the atmosphere, causing overall temperatures to fall even farther. This new abundance of large vegetation was also pulling additional CO2 out of the atmosphere via photosynthesis. As the carbon dioxide was consumed, temperatures began to fall. As temperatures decreased, glaciers began to form. The Earth's albedo increased due to the increased amount of glaciers, and ocean temperatures began to fall. Cold water absorbs more CO2, so CO2 levels fell even further. This caused global temperatures to fall even further as well.